Hello everyone. Hope our next session is going to be on MLOPS, how to manage your machine learning model. And the speaker is Abhishek Shukla. Hi Abhishek Shukla.
Hey, hi Lakshman. Very good evening. How are you doing?
Good and let me share your screen and the stage is yours.
Thank you. Okay, so guys, is my screen visible? Can you please confirm? Okay.
Yeah, your screen
O-
is visible.
Okay, so thanks Lakshman. Thanks for giving me this opportunity. Thanks for the entire team of AZCon. Uh, so welcome you all for the today's session, and the today's session is related to the machine learning life cycle. So it's in short, it is called as MLOps, and we will discuss that how MLOps can help us to manage our models. The entire life cycle process of machine learning can be managed by using the MLOps. There are a lot of tools available, but in this session, we will discuss more on the Microsoft Azure Machine Learning Studio. So let's begin. And before starting, have some brief about myself. So my name is Abhishek Shukla, and I'm a senior cloud architect in HCL Technologies. Those who would like to reach out to me over the LinkedIn, they can reach into my LinkedIn profile, and you can find it me over the LinkedIn, as well as those who would like to drop any message or would like to, they can also reach to me through this AZConf channel. And the agenda for today's discussion is like we will discuss about some background about the machine learning. Then we will discuss about that what are the various challenges which normally developers, or you can say uh, the anyone who is involved into the machine learning uh, faces such kind of challenges. And later on we will see that what is MLOps, how MLOps can help us. And in last we will see two demonstration. We will see that how Azure Machine Learning Studio can help us to achieve all or to handle all the challenges. And later on we will see that how we can create an automated pipelines by using Azure DevOps in combination of Microsoft Machine Learning Studio. So let's begin. And so if you can see, like in this slide, I have simply said that how we start, right? So whenever we used to start for anything, we have some kind of statement. You can say it's a problem statement, or you can say it's a business statement. And whenever we say that, okay, we have certain requirement, then we used to think about their solutions, that how that particular problem can be solved, how that business requirement can be met. And these solutions can have various technologies and tools available. So for an example, if we will consider the ongoing pandemic of this COVID-19, we have to predict like when the third wave will be there, how soon we can get rid of this COVID-19, or how soon a new variant of the COVID-19 will get emerge, and what will be the frequency or what will be the fatalness of that newly discovered variant. And now we have the problem statement, and if we would like to find out this problem, definitely we have to think about the possible solutions. It's a large problem. It needs a large amount of data. When we need a large amount of data, we need that how we will go to manage the data, from what are the various sources from where we will get such data, whether the data will be correct or we have to do some sort of cleaning operations with that data. And then we think about it, that what will be the best solutions. Do we need to use some sort of ready-made solutions available? Do we need to use uh, or do we need to develop our own solutions if ready-made solutions are not fulfilling our requirement? And later on we used to we come to know that okay, these kind of problems can be solved by using machine learning. So you can say that okay, we have the business requirement, and nowadays we says okay, let's explore machine learning as a solution for our business requirement. And from this particular point of time, when we said okay, we are going to use machine learning to solve our specific kind of problem, maybe it's related to COVID-19 pandemic, it's related to fraud detection, it's doing some sort of security analysis or behavioral analysis. When we said that machine learning, we are going to use machine learning, then a entire ecosystem comes in place that will be involved to achieve our solution by using the machine learning. And in short, you can say that machine learning project lifecycle begins as soon as you say that okay, we are going to use machine learning to solve our business requirement or the problem. So as you can see that in this, whenever you have that, you have to first define your requirement or you have to define your problem statement. So once you will define your task, you need the data for that. As I said, that data can come from the various places. If you can say that data may be stationary data, you have already some historical files, or data may be a real time data that is generated per hour basis, per day basis, or sometimes you can say bi-weekly basis or monthly basis kind of data. So you have to take all that data in a place, and then you have to do the exploration of data. In technical term, you can say that you have to do the exploratory data analysis on that data. Once you will explore the data, then you have to find it out that what are the various attributes of that data that can help you to solve your problem. Means you have to do a feature engineering. You have to identify that okay, these will be the features which can help you to predict, which can help you to build a specific model. Once you build a model, then the another challenges comes in, that how we will deploy this particular model, what kind of resources will be required to deploy this model. Are we going to deploy this model into a out of the box solutions provided by any vendor, you can say the AWS, Azure, or any other cloud, or you are trying to create your own infrastructure to develop your model? Once a model has been deployed, so job is still not over. You have to manage your model, and the real challenges begins here, that how you will try to manage and maintain your model, how you will monitor the model, because monitoring the model is not an easy task. You have to consider so many things when you are planning to monitor your model. And in the overall scenario, you can say that you have to manage the life cycle of the entire process, which we generally say that okay, we have to manage the life cycle of our models. Whenever you thinks that okay, we are going to build the model, and as I explained earlier, that a entire ecosystem, an ecosystem consists of so many stakeholders, so many engineers, different types of peoples. These types of peoples can be from the technical background, they may or may not be from the technical background, or they may or may not be from the specific area, or the specific technology which you are going to use to solve your problem. So typically we can say that whenever we have to develop a machine learning models, we have to use, or we have to deal three different types of people. One, you can say the data engineers, those people who are responsible to orchestrate the data for you, those people who are responsible to collect the data at a single place, so that it can be further used by the other peoples, or you can say it can be used either by the data scientist itself, or they can be used by the data architect or data engineers. When you will see that what kind of task these two peoples will be do, so you can see that the very first things you have to do is the code management, right? So whosoever is the data engineer, or sometimes you can say the data scientist, they have to perform the code management, what kind of code they are writing, either for capturing the data from the various sources, or just uh, doing some analysis of that data. So the code management, then you have to manage the data, you have to do the versioning of the data. For an example, in the current ongoing pandemic, you cannot predict future by just using a historical data of that is 1 year old. You have to look for the various conditions. You have to see that okay, how many people are already vaccinated, how many people are already have the complete vaccination course they have done, whether they have suffered with this pandemic in the recent past, or they have suffered this pandemic into the stage 1 or stage 2. uh, then you have to see that whether this particular data is the entire data is available, or the data is collected day to day basis. So whether the full data is available or the incremental data is available. Later on, you have to place that data into a centralized location. You If you are collecting the data from the various states, countries, or the geographical locations, they should be placed at a central location. So data management is a must part. Once the data will be available for you, then it comes to the data scientist. Sometimes it is also the job done by data engineers also, if they are well qualified for this particular section. But especially you need data scientists to that. And when the data scientist comes into the picture, they use to explorate the data. They have to perform certain iteration onto that data, and to perform these iterations they used various tools. In general, you can think about it that yes, we use the Jupyter notebooks normally, but if you would like to do the same things by using other tools like Python, yes, you can do by using the Pythons and the R also. But a generic solutions, or a widely used solution, is the Jupyter notebooks. And into this model building, you have to log all the metrics, you have to log all the artifacts which are getting produced during your model generations. You have to identify the various parameters, you have to identify these parameters for the various auditing, as well as you have to see that how many iterations will be required to achieve a fruitful solution. How you have to identify, how you have to modify your algorithms, your code, according to the number of features or the features selected. During this iteration course, you will find out that okay, sometimes you have to use some new features to predict your model, or sometimes you have to leave certain features. Then you have to manage the metadata, as well as you have to manage the data lineage for all. Then you have to think about the infrastructure provisioning. So you have to provision the infrastructure. When it comes to the data scientist or the data engineers, they used to as I said, they just use this Jupyter notebooks, and they say okay, this is the code, this is the data, while we are combining this data with the code, and here is our model. And right now the model is already deployed or running into in my local PC or anywhere else, and by here you can use to test it. Later on, once the model has been done, you have to do for the model management. You have to look for how you can manage your models. The model management has so many activities. The first thing is the centralized location where you will place all your models. So you can say that you have to register your models into the model registry. Then the versioning of your model. When we say versioning of the model, so it is, you can think about it like okay, it's more or less same as the versioning of the code, but it is not like that. It's like the versioning of your model. When we say versioning of the model means you have to version that which algorithm you have used to build your model, or the specific version of a model, which data set you have used to train your model. So you have to do the versioning for all those things. And into this versioning, you have to log all model metrics. That confusion for an example, you can say the confusion matrix. You have to log all the outputs. You have to log if any images are getting produced, or any parameters which are used to train your models, the specific parameters, you can say the hyperparameters. Then the metadata of your model. Once your model has been created, to deploy your model you need computation power. And how you can decide that what kind of computation will be required to host your model, you have to do the model profiling. And this model profiling will help you to identify that what will be the memory and the processor requirement. In short, what will be the compute requirement which will be required to host your model when you will go and productionize these things. Then So we have seen that okay, data engineer has done our task, data scientist and data engineers in combine have written the model is ready to productionize. Then it comes for the operational teams, so who is going to maintain and manage the model. So the very first things, the very first operation I will say, that's the governance of the model. Some authority or someone responsible have to approve or reject your model, whether they are going to use this model in production or not, or if some modification is required into the model. Then the notifications, if your model is not giving the correct output, if your model is not giving the correct uh, outcomes, then you or the developer, or you can say the responsible stakeholders or the respective teams need to be notified. So the notifications, then the model deployment. Operational teams will decide that okay, the model will be deployed manually if you are just using a small problem, or you are running into a small I will say the machine learning life cycle, or you are in a very small organization where only one or two models are uh, getting used. Then yes, you can say that okay, we will do our model deployment as a manual process. But if you are working in an organization where a number of models are running, numbers of models are running for the different purposes, then you should think about it, the automated deployment of the model. When we say automated deployment of the model, then it comes to the provision of the infrastructure. Whether you will do the provisioning of the infrastructure by manual, or you will do the provisioning in an automated way as soon as you are going to deploy a new version of your model. Once your model has been deployed, then it comes to the endpoint versioning. I have seen uh, that in a scenario when we were not able to trace back that where my model is running, or which version of the model was an endpoint serving to our test environment. So it's a practical problem. You have to think about the endpoint versioning. By having this, you can say that okay, if you have a certain set of customers which will use a respective endpoint, you can say the endpoint A or the endpoint B. How you will divert the traffic, that's not the scope of this session. But yes, you can use any traffic manager, or you can say the in Azure you can use Azure front door to divert the traffic. You can decide okay, that how much traffic will go to the endpoint A or how much traffic will go to the endpoint B. So this you or your operational teams need to take care of, that how the traffic management will be done for your model deployment. So this is a practical problem which a operational teams need to take care of. Then the smoke testing of your model. Before productionize your model, you have to do some smoke testing. Or even after the productionize, you have to test your model, whether the model is working or not, whether the model is scalable or not. If the large number of traffic is coming to your model is ready to serve it or not. For an example, the fraud detection. If your model can detect a credit card fraud at a real time, it's good. But if it is taking, say, days or weeks to detect a fraud, your model is bad. You have to re-engineering your model. You have to think about whether you have to do the reiteration for your model. Then positive and the negative unit test. You have to see that your model should be reliable. It should give the accurate result in each and all scenarios. Then the data captures means like how your model is getting used, the real time input and the prediction captures, so you can see whether the model training algorithm was correct or not. All the results which are getting predicted from your model, they are correct or not. You have to store all such things into a centralized location. And yes, you can organize all these data captures in a timely manner also. So you can say okay, that this is the data captured into this just 1 day or 2 day or in a week. Then the most challenging problem is the drift monitoring. Drift monitoring means the drift into data. When your data scientist develops or creates a model, it gets created into the standard conditions. We have is a specific data set available on which your algorithm is executed, your model gets trained by using one iteration, two iteration, or n number of iteration, and it deployed to the production. We cannot say that into the runtime or in the production when your model will get deployed, you will always get the similar data available. There are chances that your data will not be the same which you have used into the productions. So pre-processing of the data is definitely required. When you detect that yes, the actual data which is getting served to model is different than what you have used into your development environment, then you have to retrain your model. You have to iterate this process with the actual data which you are getting into a real life scenario. Then you have to see that your model should be consistent because your data is getting changed. Whether you will serve those data inputs or not, it's up to your I will say the decision that what kind of data you would like to serve it. But yes, if data is getting drifted from the standard data, you have to reiterate your models. So we have seen that we have three different types of peoples available. We have data engineers, we have data scientists. So engineers, they collected the data, they given the data to the data scientist. Then data scientists start working and creating the models, and it goes to the operational team, and operational teams start putting and start operationalizing the things for the end users. The challenges begins here. The very first challenge which you can think about it, like, okay, the how the model will get packages, right? So I will say that this is a challenge, but you can count it into the activities. So whenever a model has to be created, you have to package the model. Whenever a data scientist has written some Jupyter notebooks, and you before deploying it to the actual production, you have to package the model. You have to select that what kind of format you are going to use to distribute your model. Then you have to think about the performance monitoring, as we have seen that okay, whether your model is performing well or not. You have to version your code so that at later time when you think, for an example, that in a situation of the data drift, you can zero down that which algorithm, which code, and on which data set this particular model was getting generated, right? And what was the data which was used for train this model. Similarly, you have to do the scoring so that you can predict your data. Now, in this overall process, we have identified certain challenges. So the first challenge is the coordination challenge. We have seen that the data engineers, data scientists, and operational team. We have three different set of peoples involved here. Data engineer's job is over. Once he has put the data, he have captured all the data and stored the data into a centralized location. Now, when it goes to the data scientist is used to work onto the data. Data scientist is not think about it, okay, whether the data is coming from the right source or not. They always assume that yes, data is coming from the right source until and unless they find some anomalies in data which clearly says that okay, this is not the right data. And data scientists are used to have this their algorithms. They used to run their Jupyter notebooks. They place there into just one folder, or you can say they are placing that there into the data repositories or into your code repositories. Then it goes to the operational team. So operational teams is again blank for it. They do not know that what this data model does. They do not know that where is the data. They do not know that okay, what kind of infrastructure is required to productionize this model, how this model need to be deployed, how the traffic managements need to be done for that. So these are some challenges which you can say that's a coordination challenge between the different people's involved into this model generation process. The second challenge, as I said, deployment challenge. Nobody knows that, okay, how we have to deploy the model. Do we need to create a virtual machine? We need to deploy it into a containers, or we have to use some the clusters where you we have to deploy. And if we are planning to deploy, that what will be the underneath infrastructure required to deploy this particular model. Iterative development and experimentations, like who will do the iterative development once your model has been deployed. Data engineers have put in the data scientist has created the model, and ops team has deployed the model for you. Now, how the iterative development is going to happen, how a data engineer will come to know that, okay, data was not correct or there is some data drift, how data scientist will come to know that, okay, there are certain new features available into the data that can be leveraged to enhance the model, and how they will come to know that they have to re-experiment to their models. Validations of model, who is going to validate the model, whether the model is giving the right predictions or not, who is going to validate the model. There should be the peoples who should validate. There should be a set of processes which should validate that, okay, this particular model which we are going to deploy into the production, it's valid, and it will give the right predictions, it will give the right output in all I will say in all scenarios. Then how you will go and do the maintenance and the management of your code, how an operation team will come to know that which algorithm was getting used to train this model. If a data scientist who has initially done this modeling, he is not with the team or not with the organization, now nobody knows where the data is and what kind of algorithm was there. If a proper versioning mechanism or proper code maintenance mechanism is not getting used, then nobody knows that how it can be tracked back, that, okay, to have this particular specific version of the model, this is the specific code which we have to look into it if we have to do any enhancement or modification inside that. Reproducibility of the models. Guys, just give me one moment. Okay, so the reproducibility of the models. If you need to reproduce your model, then how you will reproduce the model? How you will identify that what will be the steps required to reproduce the models? So these are the certain challenges which you have to take care of that. Then, as we have seen, the infrastructure requirement. So yes, it is also another challenge that how this infrastructure uh, can be meet up. How to identify that what kind of infrastructure will be required to have this. And the another challenge which we have, that is the model lifecycle management. So how you can manage the life cycle of your model. After seeing all such challenges, industry come up with certain solutions, and these solutions are named as MLOps. So you can say that MLOps is not a solution. MLOps is a set of practice that can combine the machine learning, that can combine the DevOps and data engineering, and the end goal of this is to deploy your model, to maintain your model in a reliable and a efficient way, right? So we can say that the MLOps is the combination of machine learning, the DevOps practices, and it's the combination of data engineering. So you can see here like data engineering, the task of data engineers, machine learning, the task of machine learning scientist, and DevOps. the, it's again I will say the job from the operational side, but again it's a combined responsibility. When all these three stakeholders comes into one place, or they follow the best practices available for data engineering, DevOps, and machine learning, it's known as MLOps. So as I said, that MLOps is a combination of machine learning, it's combination of operational things. Then we can see that there is a the very much scope available for to do the automation of the things. So we can say the MLOps is simply the DevOps for the machine learning, and the automation can be done onto the machine learning side. Automation can be done onto the dev side, and automation can also be done onto the ops side, right? So the operational things can also be automated. Here you can see that when we have the data and the model, we can say yes, if someone has the data and the model, now developers means the data scientist can do the automation onto that, and they can create their model, they can plan, they can package the model, they can verify it, they can verify the data, they can verify the model also, and later on it can be submitted to the operational team, so that operational team can deploy your model, and operational team can plan the release of your model. Operational team can plan the configuration that is required to productionize your model. And once the model has been productionized, they can monitor your model. And if something found, they can go back to the developers, or developers can go back to the data engineers, or as a joint team, they can zero down that what is the problem, where we have to see, and how we have to rectify that problem. Whenever we are using MLOps, we have to follow certain guiding principles. Like as we have seen that yes, it's a combination of machine learning, it's a combination of DevOps, along with the data engineering, and there is a lot of scope available for the automation. But whenever you are doing some sort of automations, you have to follow some guiding principles. So the guiding MLOps also has the guiding principles. And the very first principle is the automation. So automation is like you have to automate as much as you can. And this automation get starts from the data collection, and it's get ended to the model iteration or the model deployment, and later on the model management. Now in automation, you can say yes, we can go with the continuous integration, we can go with the continuous deployment also. As soon as there will be the changes into the algorithm, it will regenerate a model. The model will go for some sort of approval process or the various approval stages, and then your model will get deployed. So the automation is the very first guiding principle for the MLOps. The second guiding principle is continuous. Your model iteration process or your model management process should be continuous in nature. It is not like that you are creating a model right now for a frequently changing scenario, and you are planning to use the same model down the line for next 4 to 5 years. No, according as per the timeline, or as per the down the line, when if you know that okay, things are getting changes rapidly, then your model deployment process or your model management or model building process, or you can say the entire process should be continuous in nature. You must version your models so that you can easily track down that what algorithm, what data is getting used, and a particular version of the model is getting used into which endpoint. So you can easily identify, or you can easily uh, give this to your customers, to the end users, that what version or what is the correct version which they have to use. Whatsoever model you are generating, it should be reproducible. As and when you need to regenerate the model, you should be able to regenerate the similar model. So it means your data, your code, everything should be available, everything should be tracked down. We have seen that there are multiple kinds of stakeholders available, and a collaboration is a challenge. to having a collaborative environment between all these stakeholders. So if you are following the MLOps, it should be collaborative in nature. Every stakeholders or every team involved or the person involved into the MLOps operations, they should be collaborative. So your environment should be collaborative. It should be scalable. Whatsoever model you are using, whatsoever data storage you are using, they everything should be scalable. Whatsoever compute you are using to train your model or to deploy your model, they should be scalable in nature. As and when the demands getting increased, your compute infrastructure and other things should be scaled. You should be able to track down the code, the data, and the model. So tracking is also a major guiding principle for MLOps. Whichever tool you are using, whichever mechanism you are using, tracking should be the guiding principle for that tool or the entire set of process. As I said, testing, that someone has to do the positive and the negative testing, someone has to do the smoke testing. So testing is also another guiding principle of our MLOps. Whenever or before deploying your model, you have to test your models. Once your model has been deployed, your MLOps says that you should be able to monitor your model. You should be able to see that how your model is getting used, how your model is behaving into the real life scenarios. Whenever we see the MLOps or whenever we use this MLOps practice, there are certain stages. So the very first is development and experimentation, exactly the same. You have created an environment and your data scientists are getting using it for development and the experimentation. It should be continuous. It should be designed in such a way that it should have the continuous integration. Whenever the data is getting changed, whenever the algorithm is getting changed, your model should be or your process should be able to generate a new model to test it. Then it should have the continuous delivery. So the continuous deployment should be there. So deploy pipelines to the target environment should be there. Automated triggering of the pipelines, sometimes it is needed, sometimes as per your requirement you can say that yes, we will use the manual triggering of this, but again it says whenever you can say that okay, by weekly or by 15 days we will create a model, or you can say whenever the algorithm will get changed, or whenever we will do certain changes into our algorithm code, we will change our model. And your model should be delivered continuously, means it should be able to use by the end users of your model, and the monitoring and the collecting data about your model performance. So the MLOps has certain components. One is the source control. Source control, like where you will keep your source code for your ML. Means whichever language you are using, either R or PySpark or Python, you have to source control that language. You have a test and build service. You have a deployment service. You can see that okay, all these are the typical requirement of a DevOps site. We need a DevOps mechanism by which we can achieve all these components. You can use any of the DevOps tool available. For an example, Azure DevOps for all these three. Then the model registry. This is something different from the DevOps. This is from the MLOps side, or this is from a registry where you will register your models so that they can be deployed or they can be used by your end users. Feature restore, so that you can say that yes, all these are the features which we are going to use or which we have already used to train our models. ML metadata service, like you can say that the data or the metadata about your the model, like when the model was getting created, what was the source code used for that model. So these are the ML data stores. So these are the component of your MLOps. Now, when it comes to Microsoft Azure, so Microsoft has a very good platform as a service, or you can say machine learning as a service, available for the end users, for the developers, for the data engineers, for the operation, the people who are from the operation side. So that is called Azure Machine Learning Studio. It's a unified tool that can be used by every person involved into the model generation process. A machine learning studio has all the features. If you are thinking about from the security perspective, so yes, it has security enabled into it. Only the authorized peoples according to their roles can go and see the entire process. Then it help you to identify and it will help you to deploy your model into the various compute targets. So you can deploy your models, you can use various compute targets uh, uh, to create your models. You can use various things there. Then it supports the experiments, and you can see that how many runs are there. You can see the snapshot, you can see what are the various output files generated, you can see the various metrics and the logs, which we will see all these things into the coming demo. Then it also has the deployment options for your model, so you can deploy your model as a web service, you can deploy model in your ACI, you can deploy your model in AKS, or you can deploy your model into the virtual machines as an attached node. And we have this security related things. So all it has a built-in data store available. If you would like to attach your own data store, you can attach your own data store there. It will help you to create the pipelines. You can say the machine learning pipelines. If you just want to create the machine learning experiments pipeline, you can create there, and you can register your data set also there. So your data sets will be versioned, they will be there. You can use these data sets to uh, train your future models or to retrain your models. And it also has a model registry, so you can register your model there. So let me jump to this Azure Machine Learning Studio to have a walkthrough of this. Okay, so you guys can see that I am inside my Azure space, and if I will go and search for a machine learning, I already have a pre-built environment ready. If I will go here and see this machine learning, I have this so many workspaces available. So first of all, you have to create a workspace. It's process the same as all or any other service. Once a workspace has been created, you have to launch this workspace, and inside this workspace, okay, so we are into this machine learning studio, and here you can say, as I said, that I have a pre-built environment. So we have some experiments here. If you will go and see the experiments, you can see that I have one iris experiments, and within that experiment I have so many runs available. So you can see that when this particular experiment was run, you can have all the metadata, all the history of that run is available to you here. And if you would like to see something related to this particular run, if I will go here you can see the metadata of this. You can see that, okay, whether when this experiment was run, the status of the experiment is completed, it was created onto the October 29th, the yesterday, how much time it has taken, what was the compute target. So I have given a name, what was the name of the file which we used into this experiment, or you can say the file which is getting used to train your model there, what was the input data set, right? So input data set, you can see that iris data set version 1 has been used, and this is the environment. Now, Azure Machine Learning offers an SDK also. So if you would like to run these machine learning experiments from outside of the Azure also, yes, you can use Azure Machine Learning SDK to control the things from the outside. If you would like to see the various metrics related to this particular run, you can see that I have captured this accuracy, precision, and recall. So here is the detail of this matrix. If there is any image generated during that, so you can see the confusion matrix has been generated. It's not that good, so let it be loaded. Okay, this is the confusion matrix which is getting generated during my model generation, And here is the output. So you can see the confusion matrix output image here. If you would like to see the logs of this experiments when it was getting executed, so here you can see the logs of the experiment, the output. So here you can see the output of the model. So you can say a serialized model file or a serialized PKL file has been generated here. You can see the confusion matrix CSV file. So the output of the confusion matrix, you can also see that what is getting generated. The snapshot will give you the details about the code, the what was the particular code that was getting used into this particular experiment, right? So and you can see the explanations, fairness, but these two features are still in preview. And if you would like to use this, you can embedded these two inside your machine learning pipelines by using the SDK, and they will start reflecting here. If you would like to rerun or resubmit this particular experiment, you can do that. Let me go here into the model. So you can see that these are the versions of the model. As soon as I will run a pipeline, a new version of the model has been generated here. And this is the versioning of the model, you can see. If I will go and click here for an example like this, so you can see that this is the version 3 of the model. And you can see all the data, metadata available for this particular model that is created here. If this particular model is deployed to an endpoint, you can see that this particular model, okay, so this particular model is not deployed to any endpoint. Let me go and see. So yes, this is the endpoint where this particular model has been deployed. And if someone who would like to test this particular model, you can simply go and test it. You have to provide the input files here in a JSON document. So this is a sample iris data set. You have to provide it, and it will let you know that okay, which species this particular data is belongs. And if you will see the data stores here, so it supports all these three data stores, and here it is the default data store. You can see that what are the various data available. So my sample data set which I have used to run and to create this, it is already available here. If you would like to generate the same by using the CI/CD pipeline, the continuous delivery of the pipeline, so yes, you can also see here. So let me go here. Here we are into this Azure DevOps, and I have some repository available here. Those who are interested to see this particular code, they can visit this repository, and this repository data will be available here. So yes, it's a very good repository from one of my friend, which I am using there. And into this pipeline, I have created a CI pipeline here. This particular CI pipeline is leveraging the Azure machine learning SDK. So let me go and open this pipeline. And you can see that the various steps which we have seen into our slide, that you have to create the environment, you have to install certain requirements. Then as I said, I am using Azure machine learning SDK. I need to use Azure CLI, so that particular steps is available here. Then programmatically I am creating a workspace, right? So I am creating a workspace inside my Python file. That Python file can also get found into the repository. But before having this connectivity, you have to connect your Azure DevOps workspace to an Azure subscription. So you have to create a service endpoint, or you can create a managed identity endpoint also. Into this step, you can see that to train our model, once your workspace has been created, means machine learning workspace has been created, or you can say the ML Studio workspace has been created. Then you have to call this for your starting your training of your model. So I am using some inline scripting, and this uh, here. Okay, let me open the another one. So if you will see it here, so that's a different pipeline. Okay, so if you will see it here, the similar thing is happening into this pipeline also. The whatsoever pre-deployed models and the environment we have seen, all those has been deployed by using this particular pipeline. So here you can see that first you need, because I am using Python language in this sample to train my model, so you have to use Python. Then by using the bash scripting, you have to install the required component of your PySpark and the Python. Then you have to install the Azure command line extension for machine learning into your build environment. Because this is a cloud hosted build, the build environment will get created onto the cloud. So to train your model, or to run your Python scripts there, you have to install all the necessary things. So once you have to do this, you can create or use the workspace, right? So either you can write the exact code into your Python file, or you can use machine learning codes, or you can use as your ML SDK. You can use inline scripting also. Once it is done, you have to create the compute environment, means you have to create the clusters here. So if you will go here and see this compute environment, you have to create a compute environment here. So if you would like to create the manually, you can create the compute environment here as manual, or if you would like to create by using the CI pipeline, you have to write you have to write the command. So you can use this particular command. And because you have to train your model, so in previous step you have created the workspace, you have created a compute target where and into this particular target your model will get trained. So you have to submit your scripts. So you have to write certain command, and you have to upload your sample, this iris CSV data, to the data store of your Azure machine learning workspace. And once it is done, here onto this the step, you have to submit your file. That's your Python file. If you are using the notebooks, then yes, by using a different mechanism, you can create your notebooks there also. You can execute your notebooks there also. You can use any C# based SDK to execute your notebooks. You can use Python based SDK to execute your notebooks there. And other means, like if you are planning to use as your data factory to execute there, yes, you can also do that. Then you have to, once your model has been trained and generated, you have to register your model into the registry. And once your model has been registered, you have to publish our artifacts, so that later on you can download all these artifacts for your local use or for your auditing and etc. Or sometimes they will also get used to create the release and the deployed or the build pipeline. So let me execute this and save it, run. So a build environment will start getting created. So my build job, the CI integrated job, is now queued. And once the build environment or the build agent will be available, this job get start executing. So you can see that job is getting start executing Python. Now onto this step, the Python components are getting installed. And once this Python components will get installed, then we will have to use this as your CLI. So once this entire things has been happened here, we will see that a new experiment is getting executed here. So you can see that we already have the experiment. I am using the same name of the experiment, and the last execution was onto the yesterday. Once we will reach out to this particular step, this iris training, then we will see that a new uh, status of in progress will start reflecting here. So let me jump back to, and if we have any questions available, we can take the question also. Meantime, our build pipeline is getting generated.
Yeah, hi, Abhishek.
Hello. Yes, you are audible.
Able to hear me, right? So there was no any questions at present, so that you could go with your presentation as further. If there was, I will get notice to you. Sure.
Okay, sure, sure. So let's wait couple of more minutes so that this particular pipeline will get executed. Uh, the roughly it will take somewhere around sometimes 8 minutes, sometimes 12 minutes also. So we will see that before closing of this presentation, it will get done. Okay, so right now we are on to this particular demo. Those who would like to refer this, they can go and refer this DevOps repository for the respective code. Okay, so if anyone have any questions, they can directly reach out to this chat section, or if they would like to reach out after this particular session, they can reach out there also. And let me back to, okay, so let me see, like test data is available there. So you can see that yes, existing data set, it will say that data set is already existing. Okay, status complete, iris training, and let me go here. Okay, so you guys can see that a new experiment run is running here. This is currently queued, and I don't think so that it should take more than 2 minutes. So once this particular execution will be created, this experiment will run. And right now we have only the 4 versions of my model available. As soon as this will get created and we will reach out to this particular step, the registering model into this model registry, we will see a new version of the model that will be the version 5. If you would like to deploy that version, you can simply go it here and you can deploy it here. You can select whether you would like to deploy it into the web service. So you can select it, and you have to provide the container instance or the Azure Kubernetes cluster. You have to select your script file. So it will be the score file. So you have to go here and deployment. Mhm. And you can select your conda deployment file. So it will have your conda requirements. So all the dependencies, and you have to give this name. So I will say azconf demo, and a deployment will get created. Once a deployment will be done, so this particular model, of course, I am using the previous model to finish in time. So once this particular model will get deployed, so deployment started successfully. And once this model will get deployed, we will see a endpoint here. And that endpoint can be used to test our data, right? So right now this is under development. So let it be. So the pipelines is getting run here. And here is our sample script, which we can use to test our model. So let me go here and go to this model 3, version 3, endpoints. No endpoints here. So you can see this is our sample. And if I will put it here, my model will let me know that, okay, this particular specifications is related to the species 1 of this iris flower. If I will do certain changes here or any changes.
Sorry to interrupt you, Abhishek. We have a couple of minutes for our next session to get it started. Hope you could
Mhm.
wrap it up.
Yeah,
Thank
sure, Lakshman. So as you guys can see that as soon as I am changing some input parameters, my model is predicting that, okay, now the species has been changed here. So you can see that after the deployment, the model is working fine. So either you can use the continuous deployment pipeline for this model deployment, or if you would like to have, you can use the manual deployment also. By having this, I would like to conclude this particular today's session. So if anyone have any of the questions we can have, or Lakshman, we can I have done with this presentation.
Okay. Thank you, Abhishek, for your valuable session, and I hope there was no questions from the audience side. So maybe where they are able to know how the machine learning model works and how can they able to automate, because right now it's everything is going on automation. Hope this all the information which you are able to cover, a lot of people is able to gain those information and they can take it from there. So I really appreciate your time and for your valuable session. Thank you, Abhishek, and have a nice
Yeah,
day.
thanks Lakshman, thanks everyone.
So next we are going to move up with our next session. It's going to present by Andrew.